So, hi guys, welcome to a session on jump search. So, what is basically a jump search? A jump search is a search algorithm that is used to search for an element in sorted arrays. The basic principle here is that you should check for a lower number of elements than that you do in a linear search. Now, to achieve this, what we can do is that we can use certain properties of sorted arrays to skip say a particular number of elements during each iteration. So consider the example wherein we have a sorted array of size n and we have to find the element x. Now we have to come up with the jump size, which is basically the number of elements that you have to skip in each iteration. Now this jump size is always taken to be the square root of n. Why is it so? We'll come to that part later. So now what we do next is that we search at indices that are in multiple integrals of m, that is 0, 2m, 3m and all the way till the end of the array is reached. So now there is a need for a condition to stop this iteration, and this is the condition there. What this condition says is that the element at the index that we have just jumped to, if that element was greater than or equal to the element that we are searching for, then this condition is reached and the iteration stops here. So for this particular example, what we are trying to do is that the iteration will stop when the index reaches m into k plus 1. So this is basically the use of the array property here, sortedness property. So I have a demonstration which will help you understand this better. So yeah, now consider this array. This is basically a sorted array. So let us try and find the element 77. So now the size of this array is 16. So we have to have a jump size of 4, which is the square root of 16. So let us start checking for the element from 0. So we go from 0 to 2. Now basically we should jump for all the elements till we reach an element that is greater than 77. So 0 to 2, 2 to 8, then 34, then 89. Now here we find that 89 is greater than 77. Therefore, we stop with the jumps and we do a backward linear search to basically get the element 77. Coming to the coding part of jump search. So here I have the coding required to perform this jump search. So basically there are two functions, the function search element and we have the main function here. The main function is all about getting the array as an input, then the element to be found also as an input. Now we are passing these two along with the array size n as the parameters to the search element function. So yeah, what happens in the search element function? So what basically we have a while loop to perform the iterations. Now we have a variable called step, which is the square root of n. Now this is basically the jump size. So we start from the array index 0. So array of so m will start from 0 and upon each iteration m will increase by the step value, that is square root of n. This process continues until this condition fails. Any of these condition fails. So either that array index value at an array index is greater than the element that we want to find, that is x, and or that we have searched throughout the array and we have not found such an element. These are the two cases where it fails. Now this if condition here, that is basically for arrays whose size are not perfect squares. So that helps in ensuring that you are always giving a valid array index if at all there are elements left behind after the last jump. Now coming to the for loop. So the for loop is basically to perform backward linear search. So we are starting the iterations from m, that is the place where we jump to and the condition failed. So we want to perform linear search till a maximum of m minus step times, because we cannot go to the index of the previous jump, because we already know that element at that index is lower than the element that we are searching for. So yeah, here if now we are iterating in reverse, if we find that array, then we are returning the array index, else we are returning -1. Now let's see how it works. Let's see. Hi guys, so let us come to the coding part and implementation of this. So we have seen the coding part, now let us come to implementing this. So yeah, okay, so now basically I want to enter the array size, that is the number of elements in the array. I'll try to choose a non-perfect square, so let me choose 7 say, and I'll make it ordered so that it is easier to just know the index. Okay, so now this is basically the array of size 7, starting from element 0 to 6, all the way progressively increasing by a factor of 1. Now the element to be found, say I give the element 4, now element at index 4. Now here I have given the element such a way that it is basically the index numbers itself. So 4 is found at index 4. Now let us try giving a searching for element that is not in the array. So let me give 14 basically. Okay, so yeah, now let us try to find the element 15. So this element does not exist in the array. So yeah, hi guys, coming to the part of why we need jump search. We basically have binary search, which has time complexity of log n. Now log n is basically far better than square root of n. So why do we even need jump search? Now to answer that question, let us move on from ordinary data structures as arrays. Let us consider a case of say circularly singly linked list. So yeah, in a case such as of this, backward jumping would be a lot costlier than forward jumping, because say I have a circular linked list. Now if I'm here to get back to this element, I would actually have to jump all the way in a circle to get back here. So now this increases the time complexity of backward jumping. So if this such a circularly single list is sorted, then in that case we can make use of the jump search. In jump search, if you modify the algorithm a little bit, all you have to do is do only one backward jump. So for those of you wondering what I'm talking about, let us perform a little modification to the jump search algorithm that we just saw. So if this was the array that we are talking about, then what we did was, say the element I found was here. I started here, I moved in jumps of, let it be 0 m. Now this will be m. Now I jumped to size 2m, I found the element here, so I did reverse search from here. But instead of doing a backward linear search from here, what I could do is that I could do a backward linear jump all the way to the previous index, that is here. Now from this index, now I can do forward linear search until I find the element x. So this reduces the number of backward jumps to we make all the way to a maximum backward jump necessary of 1. So this is where jump search algorithm is better than binary search. This is one of the use cases there.